All right, guys. So if we were to notice previously, you're going to see that we worked with these typical integrals when you were integrating whatever type of a function of this nature, giving us what is equivalent. These integrals we could integrate direct because you are given a specific answer that whenever you're integrating this nature, you are supposed to obtain something of this nature. But these integrals that we are seeing here can be worked with the substitutions under our trigonometry, working with the substitutions, that is the sine and the tan. All right, so we want to see how can we simplify these integrals using the substitutions of the sine and the tan. All right, so like I said, we are just going to have this, the introduction of the sine and tan substitutions. All right, so this is something that you can actually work with from your integrals. Let's say you are given, if you are given a specific question that use this concept, use the substitution of the sine or the substitution of the tan, then you can opt for this. But if you're not given that, you can opt working with the formulas, because already we are given these integrals in form of formulas. So what you just need is to substitute whatever that you're given in terms of the formula. I talked about these integrals from other past exam papers, if you still remember. So this is it. Let us consider these integrals. Like I said, you are going to notice that in these integrals, whenever you are integrating something of this nature, let's say we are given the integral of 1 over the square root of a squared minus b squared x squared. You're given something of this nature, which is integrated with respect to x. So this is the same format that you just see with this dx here written on top. It's just one and the same thing. Having dx on top is just same as it was 1 over this. All right. So whenever you are given this condition, you are going to use this following substitution in place of x. Take note, it's a substitution that you're going to have. So whenever you're given this format, you're going to have the substitution in place of x. X is equal to a over b, the sine of alpha. So this is the substitution that you're going to have in place of x. All right, so we're going to talk of an example. How are we going to apply this substitution? All right, again, if you are given the integral with respect to x of, let's say this is a squared plus b squared x squared. So we are integrating this with respect to x. Our x that we are going to substitute is supposed to be a over b, the tan of alpha. All right, then the last one that we are given for an integral, if you're given the integral of the square root of, let's say we are given the square root of a squared minus b squared x squared. With respect to x, we are going to see that our x is going to be a over b, the sine of alpha, which is the same as this one that we had in the first place. So these are the three most integrals that you're going to work with in your syllabus. I think this is easy to grasp, like a over b sine alpha, a over b tan alpha, a over b the sine of alpha, for just these three. So as we can see, it is supposed to be a substitution in place of x. We are to substitute a over b, the sine of alpha. So if you have to take a consideration, it means the x is going to be affected. You are substituting whatever that you're given, but there is now the tan of alpha, it is the sine of alpha, whatever that you're given. It is going to affect our question in the sense that you are going to have this in terms of alpha. So we are going to have this in terms of alpha. And that cannot be integrated because this is with respect to x. But you substituted x with something that is of alpha. So the question is, How are we going to integrate? Because this is now in terms of the moment that you substitute, it means also you must express this also in terms of what? In terms of d alpha. So express in terms of d alpha, that is the derivative, with respect to, remember, dx means with respect to x. So d alpha with respect to alpha. Okay, so let's consider just one or two questions. How can we apply this? As you can see, it is a straightforward question that you just need to follow up the steps. Let us consider that you're given to integrate 1 over 9 plus 16x squared with respect to x. So if you're given this with respect, it is the same thing as what we can see from that presentation. 1 times dx is the same as we're given dx over 9 plus 16x squared. It's the same format. So if we are to consider which part are we going to take where we are given this condition, the format that you are given, it is exactly of this part 2 that you're given, number 2 there, where we are given dx over a squared plus b squared. So if we are to express this in terms of a squared, b squared, x squared, this is 9, this is 16. How can we write this as a squared and number to the power of the same 9 that we are seeing are the same as 3 squared? The same 16 that we are seeing, it is the same as 4 squared. So you're supposed to indicate this in terms of a. So if you do not want to have a challenge, you can just indicate this is the same as the square root of 9 is same as 3 squared, 16 is same as 4 squared, x squared, so that you properly see what is representing your a, what is representing your b, what is representing your x. So this is like a, b, and this is x, like a squared, b squared, x squared. So a is 3, b is 4, x is 3. X is just x, I mean, if you understand that way. So the question is, what are we going to do? The substitution of this is supposed to be x is equal to a over b, the tan of alpha. So that means we are supposed to obtain the x from this condition. So our x is supposed to be given as a over b. Our a is 3, our b is 4. So this is 3 over 4, the tan of alpha. That is what we're having there. This is our x. Like I said, the moment that you are going to substitute the x here, it is in terms of alpha, this x. So it means also you must have dx written or expressed in terms of what? In terms of d alpha, with respect to alpha. So that means from the x that we are given, we are supposed to obtain the derivative with respect to alpha, the derivative of x with respect to alpha. In order for us to express dx in terms of d alpha, we must have the derivative of x with respect to alpha. All right, remember these are your integrals. Tan does not change. This is sec squared, so it's going to be sec squared alpha. So we can express dx in terms of what? D alpha, that is make dx the subject. So dx is equal to what? Just cross multiply. So that will be 3 over 4 sec squared alpha times d alpha, like this. So this is dx in terms of d alpha. The moment that you make a substitution to say x is equal to, the statement has changed. The expression that you're given has changed. It is now in terms of alpha. So in order for you to integrate, later on, we are going to see that in order for us to integrate, we can't integrate because this is with respect to x, but x is now written in terms of alpha. Okay, let us make our substitution and see. We are going to have something of this nature. You were actually going to obtain, let's say we did not substitute this. I want you to see what we're going to have. You were going to have dx over 9 plus 16 x squared. So x squared, that means you are going to square this. right? This is x, so x is squared, we square this 3 over 4 tan alpha squared. So that means 3 over 4 squared, 3, that is going to be 9 over 16 tan alpha squared. So this is what you could, also the tan is affected by what? By the square. So that means in this case, our x squared is the same as we are given this. All right, let's just save a bracket here. This is 9 over 16 tan alpha squared, or tan squared alpha. So as you can see, this is in terms of alpha, but this is in x. So it's impossible for you to integrate. That's why I'm saying you are supposed to have this dx in terms of what? In terms of d alpha, in terms of what is representing alpha, so that whatever that you're going to integrate, it is with respect to alpha. So dx in terms of alpha, we got what? Dx in terms of alpha, this is our dx here. In terms of d alpha, or in terms of alpha, you got 3 over 4. That is 3 over 4 sec squared alpha d alpha, like this. So meaning to say, this can be integrated in terms of alpha. Everything that we are given here is in terms of alpha. But lucky enough, from these substitutions that we just made, I want you to see something here. From the substitutions that we just made, if we are to simplify, what are you going to have? Okay, this is 3 over 4 sec squared. 3 over 4 is just a constant. Does not affect anything. So you can even write it outside of the integral. So that means we're going to have 3 over 4, the integral of what is remaining here. It was just supposed to be like 3 over 4 over 1. So 3 over 4 over 1 is just 3 over 4. So we have the integral of what? The integral of sec squared alpha d alpha, like this. Then let's simplify our body mass here. These two can be simplified. The 16 and the 16 can cancel, meaning to say you're left with 9 plus 9 tan alpha squared, tan squared alpha, like this, where 9 and 9 is common. So you can factor out the 9. So if I'm to factor out this 9, I'm going to remain with what? Factor out 9 here, that's a 1, plus factor out a 9, that's a 1. So meaning to say we are remaining with what? Tan squared alpha, like this. Okay. This here, if you are to consider the part of your trigonometry here, we are going to see that a 1 plus tan squared is equivalent to sec squared, or a sec squared is equivalent to 1 plus tan squared. So either way, either you're going to change this into a 1 plus tan squared, or you're going to change a 1 plus tan squared into a sec squared. But at the end, you're going to see that these two are the same. This is the same as what? Sec squared alpha. So definitely these two we're going to cancel. They are the same. 1 plus tan squared alpha and sec squared alpha are the same. You don't need to write that stage. By just knowing your identities, you know these two are the same. So meaning to say we are left with a 1 over 9. Remember, this is our sec squared, which is the one that canceled here. So you're left with 1 over 9. So the 1 over 9 is just a constant, just like what we had on 3 over 4. So you can also take it outside of the integral. So that means what are we going to have if we take it outside of the integral? There's a 3 over 4 there. Take outside the 1 over 9. So it's simply multiplying to 1 over 9. So that's 3 over 4 times 1 over 9. So this was going to give us 1 over 12 at the end. If you have to simplify this, that was going to be 1 over 12. The integral of what? Remember, we canceled everything. We took the 1 over 9 out of the integral. So what is left inside of the integral? Nothing. It's just a 1. With respect to what? With respect to alpha. We are no longer having x. This is alpha that we are having. Remember, this is with respect to alpha, even though the part of alpha, the trigonometry, played its role, and we managed to cancel this part. This is not us. It's just the trigonometry which canceled on its own. But it was with respect to what? with respect to alpha. Yes, it's cancelled, it's true, but it's with respect to alpha. So meaning to say, if it was with respect to x, integrating 1 with respect to x, that is x. So this is with respect to alpha. So if you integrate 1 with respect to alpha, what are you going to have? This is alpha plus the constant of integration. It's just like you're integrating 1 with respect to x. That is x plus c. But whatever that you're obtaining, it is in terms of alpha, not in terms of x. This is an integral which was given with respect to x in terms of x. Meaning to say our answer also is supposed to be in terms of x. Our answer is supposed to be also in terms of x. So the question is, when we made a substitution, it's like actually you are introducing something to say, let x be this. You introduced x as part of your simplification. This was not part of the question. You introduced like x is equal to this, which is not part of our simplification. So from here, let us go back to the x that we had so that we obtain the alpha from there, because we need to replace this alpha and replace it in terms of what? In terms of x. So it must be in terms of x. So from the previous case that we had, we are saying x is equal to this. So let us find alpha from there. If x is equal to 3 over 4, the tan of alpha. What is alpha? Okay, think of your trigonometry on its own. If you're given that tan alpha is equal to 2, how do you find alpha? Alpha is equal to arctan of 2. That is the idea there. So meaning to say from a single trig, I can determine the angle that is affected here. Alpha is the angle. So let's remove the 3 over 4 because it's affecting our tan. Tan is no longer a single term because of this 3 over 4. So remove 3 over 4, multiply by 4 this side, that will be 4x is equal to 3 over, then you divide by 3. So that means you're remaining with tan alpha there. So what is alpha? If tan of alpha is equal to 4 over 3, if we are to say tan alpha is 4 over 3x, what about alpha? Just like what I said before. So to obtain the angle alpha, it is going to be arctan. That is arctan 4 over 3x. This is your alpha in terms of x, arctan. We are having this in terms, it's now in terms of x. So meaning to say, we can substitute this in terms of what? In terms of where there is alpha, we can substitute our alpha. So that means there we are going to have arctan 4 over 3x. So this is 1 over 12. Then we have got arctan 4 over 3x. Just like that, plus the constant of integration. So these are some of the integrals that we can be given. As you are just given, use a tan substitution, play around with this, you can obtain whatever simplification that you're given. So what you need is to make sure that you understand the stages that whenever you substitute something which is not part of your integral, it has changed the question. So meaning to say also find or express dx in terms of the same unit or in terms of the same letter that you're given. If this is in terms of y, like that, that substitution that you make of the u substitution, everything changes. So these are the typical questions actually that you might have. So you're going to have another typical exam question that you might be given. So it's not like these substitutions are wrong to use. No, they're fine. We can work with the substitutions, but as we can see, like I said before, there are formulas already for these. So instead of you working out this in terms of an exam, you are just given a question. The question is not specifying. Use this. You can use the formula. you can stick to the substitutions, which is fine. All right, so quickly having this, it is a similar question, but only that sometimes there are some simplifications that you just need to get rid of. So let's say it was the integral of 1 over 2 plus 4x squared with respect to x. So as you can see, it is the same as the previous question that we had. So it's going to be dx over 2 plus 4x squared, like that. So having our a and b from this format, a squared, b squared, 2, how can we write 2 in terms of a number raised to the power of 2? Is it possible? So unlike a 4, 4 is a direct number that we know that 4 is same as 2 squared. So whenever you give a number such as 3, such as 5, such as 2, such as 7, these numbers, they do not have, like we do not have exact square roots of these numbers. They are not perfect squares. So how do we express these numbers as squares? You introduce the square root, then you also square the number. Introduce the square root, square the number. There's nothing that you have changed. Remember the concept of a square root. The square root of a number raised to the power of 2 simply cancels, meaning to say you are still having the same number 3. The same number 2 that we are seeing here can be written as square root of 2 squared, which is still the 2. Nothing has changed. So in this case, just working or focusing with this part of the a squared plus b squared x squared, it means the 2 was going to be written as the square root of 2 squared. What about 4? How can we write 4 as a number to the power of 2? 4, the square root of 4 is 2, so that is 2 squared. So in actual sense, each and every number that you were having, it was written in this format. Each and every number that you were having before. 25, you were just writing the square root of 25 squared. But it's just that we know the square root of 25 is 5, so it's 5 squared. But it was one and the same thing. So if you're given a number now like a 2, the square root of 2 squared, we do not know the square root of 2 direct. So it just remains as it is. But it was applied on each and every number. Take note of 9. The square root of 9 squared. You introduce the square root. So the square root of 9 is what? Is 3, which is 3 squared. So yes, it's actually something that you had before, but only that we are not seeing that. So I just hope this is fine. So there we've got our a, our b, and our x, remember, from these terms that you're given. So it means from the substitution, it was supposed to be a over b tan alpha. So x is supposed to be a, which is the square root of 2, over b, our b, which is 2, then tan alpha, like that. So this is what you're going to have. So as long you have presented this, you have got your x. What is next is to determine dx in terms of alpha. So the derivative of x here in terms of alpha, this is a tan, like we said before. The derivative of a tan, it's a sec squared. So that's sec squared alpha. Just like that. So meaning to say I can have dx if I cross multiply or just multiply dx this side. That is going to be square root of 2 over 2 sec squared alpha d alpha, like this. This x that we are having, we're going to substitute, and also dx, as we saw that we are going to need these two into our substitutions. All right, so let's substitute the integral of, in place of the dx, this is what we got, the square root of 2 over 2. That is a sec squared alpha, d alpha, like this. Then we got this part, which is 2 plus, so that is 2 plus 4, x squared. So this is x. So what about x squared? That is means square root of 2 over 2 tan alpha squared. The square root of 2 to the power of 2. This is the square root of 2 to the power of 2, like this. What are we going to have? So this was going to simply give us a 2 over a 4, which is simply 1 over 2. So the calculator, guys, is there. If you simplify this direct on your calculator, you're going to obtain 1 over 2. So meaning to say this part, if we were to simplify this, it was going to give us a 1 over 2, square root of 2 over 2 squared. You put it in a bracket on your calculator, it was going to give you 1 over 2. Then the tan also squared. So it's tan squared alpha like this. But remember that the x squared here that we are going to substitute, it is multiplied to a 4. There's a 4, x squared. And our x squared there, we got 1 over 2 tan squared alpha like this. Okay, so this is just for a simplification. But if you do not know, if you do not this, there's no need for you to actually simplify this. You just have to substitute direct. All right, so this is it here. If you're to simplify again, you can take out this out of the integral. The square root of 2 over 2 is a constant. So you're left with the integral of a sec squared. On top, that's sec squared alpha d alpha. All right. Then what else? We have got the 2 plus 4 times 1 over 2. That's a 2. So if you had to multiply this 4 times 1 over 2, it was going to give us a 2. All right. That's 4 times 1 over 2, which is a 2. So that's 2 tan squared alpha. As usual, you can see this is common. Factor out this, you are left with 1 plus tan squared alpha. So this part here, it gave us a 2, which is 2 plus 2. All right. But if you factor out the 2, you'll be left with 1 plus tan squared alpha. So like I said before, the tan squared, 1 plus tan squared alpha and sec squared alpha are the same. This is equal to this. It's an identity. Sec squared alpha is equal to this. So it means these two are the same. They can cancel. So you're left with 1 over 2. Take out the 1 over 2 out of the integral. Let us just take out this out of the integral. It means we've got the square root of 2 over 2 times 1 over 2. So it was going to give us square root of 2 over 4. The integral of what? This whole part here is simplified. We canceled everything. We took out the 1 over 2 out of the integral. So we just left with the 1. With respect to what? With respect to alpha. So these are the simplifications that you will just need in these substitutions. A 1, when integrated with respect to alpha, that means it is going to give us an alpha. So that means we are left with the square root of 2 over 4 times alpha plus the constant of integration. Where alpha is not part of our question, it is something that we introduced, where we introduced our x here. It's like we are letting x to be equal to this. So from this part, we must write alpha in terms of x. Okay? So what is going to be our alpha? I talked about this. We're going to multiply this side. That will be 2x. You divide by the square root. This is equal to tan alpha. So make alpha the subject. It means alpha is equal to arctan. Remember, alpha is the angle. So to find the angle, it is arctan of what you're given there, 2 over x, 2x over the square root of 2, I mean. So if you're to simplify this, you can even simplify this further on your calculator. That is the square root 2 over the square root of 2, which is going to give you the square root of, which is just going to be the square root of 2. Yes, you can just write it like this, but if you're to use your calculator, 2 divided by the square root of 2, it is just the square root of 2. So there we have got arctan square root of 2 times x. Representing what? Representing alpha. So meaning to say, where we have the alpha in this case, we're going to substitute with the arctan square root of 2 x. So this is square root of 2 over 4. Then in place of alpha, we got arctan. So that is arctan the square root of 2x plus the constant of integration. So as you can see, the answer that we are having is in terms is in terms of x now. So this is what you just need. So the simplifications can differ. It's not like always we are going to have only this part of the arctan. I mean, the part of where you're using the substitution of the tan. You can even have the substitution where the sine is considered. Where the sine is considered. There's so many different typical questions. You just have to work questions where there's a challenge. Let me know so that we can work from that question. Let's say we are given, let's just consider question 3, the integral with respect to x of the square root of. So let's say this is the square root of 9 minus 16x squared. So using the substitutions, we are saying of this format, x must be equal to a over b, the sine of alpha. So again, we just need to make sure that we properly have, or we properly see what is representing our a and what is representing our b. So the 9 is same as the 3 squared. The 16 is same as the 4 squared. So there we can properly see that a squared, b squared, x squared. This is our a from a squared. This is our b from b squared, and this is our x. So like I said, there are formulas that you can use, but when the question is specifically mentioning that use this substitution, you do not have option. You are now opted for this. So of this format, we are going to let our x to be equal to a over b, sine alpha. All right, so letting our x to be equal to a over b, our a is what? That is our a is 3 over b, our b, which is 4. Then there's a sine of alpha. As we saw from the part of tan, we are going to need the derivative with respect to x from the x that we got with respect to alpha. So the derivative of x with respect to alpha. Remember, if you differentiate sine, that's a cos. So that's 3 over 4 cos alpha, just like that. So dx cross multiply or just multiply with the dx this side. So that means, with the d alpha, so that's going to be 3 over 4 cos alpha d alpha. This is what is representing dx. That's our dx. So it can be substituted now. There are two things to be substituted into our integral. The x that we had and the dx. So meaning to say, in place of the dx, we're going to have this as 3 over 4 cos alpha d alpha like this. And this is the square root of the 3 squared. Remember, this is just a presentation that we just got here, but these are 9 minus 16. So these numbers just 9 minus 16 x squared, not x, but x squared. So meaning to say from the x that we are given here, we are supposed to square. Guys, squaring this, that will be 3 over 4 squared. That's 9 over 16. You square this, that will be a sine squared alpha. So taking this 9 over 16, that is 9 over 16 sine squared alpha. That means this will cancel the 16 and 16. Again, we can take out the 3 over 4 out of the integral, 3 over 4, the integral. There we are going to be left with the cos of alpha with respect to alpha over the square root of. All right, since we canceled the 16 and the 16, that means we are left with 9 minus 9. So you're going to even factor out the 9 because it's common. We are left with 1 minus sine squared alpha. Remember, there's 9 and 9 here. So you're going to factor out that one. All right, so let's see what we are having here from this simplification. If you're to consider that's 3 over 4, the integral of the cos of alpha d alpha. All right, so there we have got the square root of what? The square root of a 9, which we know that's a 3. So meaning to say, under the square root, there is a 1 minus sine squared, which is left. The square root of 1 minus sine squared alpha. What does this part mean? 1 minus sine squared alpha. From our trigonometry, again, we can consider from the sine squared plus cos squared, 1 minus sine squared. On this side, it represents cos squared. The cos squared of x is equal to 1 minus sine squared x. So meaning to say, where there is a 1 minus sine squared, there is a cos squared. So in place of this, there's a cos squared. We are simply seeing a cos squared. And we know the square root of a cos. Remember the square root and the square. That means we've got cos x there. So this was alpha. So that means we've got cos alpha. So in place of this whole part here, under the square, because there's a square root, it is going to be the square root of cos squared. And the square root of cos squared is cos alpha. So meaning to say, you are going to remain with cos alpha there. The cos and the cos are the same. So thus we've got 1 over 3. So as you can see, this is the simplification similar to the previous questions that we had before. So thus you're going to take 1 over 3 out of the integral. So what are you going to have? 3 over 4 times 1 over 3, that's 1 over 4. So you've got 1 over 4, the integral of what? This is no longer part of our integral. Remember, we took it outside of the integral. So that means we are just left with a 1. With respect to what? With respect to alpha. So just like the previous conditions, integrating 1 with respect to alpha is going to give us an alpha plus the constant of integration, where we need to substitute alpha from the x that we introduced as part of our question here. Say let x be this. What will be alpha in terms of x? If x is equal to 3 over 4 sine alpha. So multiply by 4, this will be 4x. You divide by 3. So that means we are left with the sine of alpha. To have the angle alpha, it means we are going to have arc sine on the other side. So that's arc sine 4 over 3x. So in place of our so this is just like we are back to our trigonometry there. Remember, if you are given from your trigonometry there, if sine x is equal to 0,5, how do you find x? X is equal to arc sine 0,5. X is the angle. So here we are not finding exactly x. Alpha. We are finding that in terms of x. It's not an exact value that you're going to have. It is just in terms of what? In terms of x. So alpha as arc sine 4 over 3x. We are going to substitute in place of what? In place of alpha here. So remember, all right, so here guys, remember I'm at this condition here. It's now taking what we integrated previously. So this is where we are. So if I am to integrate this, if I'm to substitute this, that is 1 over 4. Remember we got arc sine 4 over 3x plus the constant of integration. So these are the substitutions that you can actually have. There's so many questions that you can have, different substitutions. But if you take note now, these substitutions are later on expressed as formulas, which we can represent in terms of formulas. So we shall have another part where we can consider our formulas. How can we apply these formulas instead of using the substitutions? But like I said, we actually worked with these formulas before in some of our integrals. If you consider them, just go through. But we shall have a different type where we shall actually separate the formula and the substitution so that you see where it is necessary and where it is not. But as you can see for now, the substitutions are best when you are given to use them. The question is actually on using that substitution. Use the sine, use the tan substitution, or it's just using the trigonometric substitution. You are the one who is to know which trigonometric substitution is it that I'm working with. On that question, you do not have any option to work with. You are left with the substitution. So like I said, there are 3 substitutions that you just need to work with in your syllabus. Let's just try to work as much questions as we can till we meet again.